Okay, which questions do you need help with for exercise 9A? What is everything? Question 3? C. Okay, let's start with 3B. 5 tangent x plus 6 equals to 2 over cosine square x. Okay, I need suggestions how we can do this. Huh? 1 over cosine square x is secant square x, lor? Oh, okay. So because you have over cosine square, this is actually the same as 2 secant square x. Now why would I want to change this to secant square? Because secant square is related to tangent square. Why would you want it to be tangent square? Okay, listen this is the thought process which is important for you to solve. Cosby, you asked whether there's a series of steps. This is the thought process. I change cosine square to secant square. They are related. I change secant square because I can change it to tangent square. And I change it to tangent square because there's a tangent in the question. Okay, so here we have 2. What is secant square x in terms of tangent square? Okay, tangent square x plus 1. So on the left hand side, I've got 5 tangent x plus 6. What kind of equation is this? Yeah, this is quadratic. Which means that I will have tangent x equals to something or tangent x equals to something else. 2 possible values. And then you solve accordingly. That's all the help you're getting for 3B. Okay, next. Question, did somebody require 3C? 3C. 3 cosine x plus 3, 5 over cosecant square x. Okay, what can we do? Okay, so Kevin says we change this to 5 sine square x. Why would he want to do that? Sine square is, Rissy? Sine square is connected to cosine square. Why would we want to change it to cosine square? Because you make it all in terms of cosine, then you get quadratic again, right? Okay, so that's what we are going to do. Sine square, and in terms of cosine square, what is it? 1 minus cosine square x. Then you have a quadratic again. So you will get cosine x equals to something, or cosine x equals to something. Yes. Yes. And you can solve. So for those who require help for 3B and 3C, after looking at this, do you think you can manage now? Is this something that you can do by yourself also? If you think through what is required and what we have learned. Yes. Then? Okay, so what he is suggesting is that he does whatever he can, whatever comes to mind without a strategy. You see, can change, then you change. For example, in this question, well, we could have done this. This is 5 over 1 plus cotangent square x, right? We could have done this, right? Is it going to help? No. How does cotangent square make things easier for us as compared to cosecant square? This one changed to cosine square x over sine square x, right? And then how? Then you change this one to become 1 minus cosine square x. Then you, very complicated. You got a fraction in a fraction, and I don't know whether you will be able to simplify eventually. Nothing wrong, but it is a question of whether you can solve eventually. Okay, so next. Anybody needs help for 3D? If yes, raise our hand. 3D, don't be shy, okay. 3 over cosine square x. Okay, what can we do? What do you want to change it to? But this is cotangent, it is not cotangent square. Okay, any other suggestions? Just raise our hand, otherwise you'll be drawn out. Yes, Kevin? Okay, so this is 7 plus 4 sine x over cosine x. Okay, what do we do from here? Any suggestions how we can tackle this? I'll give you all time to think. So now the plan is, let's change this to 3 secant square x. Are you able to do this step? Is it clearer for you now? What shall we do? We got cosecant to become. Okay, be careful with what I say. Tangent square x plus 1. Quadratic can do again. Can? Yes? Yeah, you are absolutely right. Wait, what can we do over here? Change cotangent. It looks like the only thing we can do is to change cotangent. What can we change it to? Okay, cosine x, then cosine x over sine x equals to 2. Then are you okay? From here we times sine x because we got a fraction, right? So sine square x plus cosine square x equals to 2 sine x.
So 3
Yes? What?
Wait, can you split the bracket? Split them.
What do you mean split the bracket?
No, they are.
Okay, this step all okay? Agreeable? Agreeable? Then numerator times numerator, denominator times denominator, right? Correct? All agree so far? What shall I do with that denominator? Sine square x plus cosine square x equals to 2 sine x. Can do from here? What do you think the next step? Is this quadratic? Change cosine square x to sine square x, is it? Using what formula?
Sine square x, the one minus sine square x. Sine square x plus cosine square x. Oh yeah, okay.
You want to use this one, is it?
Yes.
Hello, you all got this from cosine square x plus sine square x equals to 1, right? Then isn't this 1 already?
Yeah, that was like, isn't it?
Why you want to go such a big round? Correct or not? Correct or not? Okay, so remember, try to save some steps.
But later the marks how?
No, this totally okay what? This is equal to 1.
Sine x equals half.
So I can do? Okay, you do yourself. So you get all the answers again, huh?
Which I can just go through first because if I get sine x equals half, then
Sine x equals to half. Quadrant 1 and quadrant 2. Let sine alpha equals to half. Alpha equals to blah. So x equals to something or something and blah 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 blah. Okay? That is for part B. Who needs part C? Part C, anybody? Don't be shy, raise your hand. For okay, what can we do from here? Tangent x change to what? Okay. 4 plus sine x, cosine x, 4 cosine x. Okay, what do we do next? Multiply by cosine x. Okay, let's try. Cosine x plus sine square x, 4 cosine square x. What next? Change? Do I have sine x, eh? Oh, change sine square x to become? 1 minus cosine square x equals to 4 cosine square x. What kind of equation is this? Quadratic. And solve again lah. Dot dot dot, cosine x.
Or you time
Because you times cosine x already. Then become sin x cosine x.
Sin x cosine x over cosine x cosine x.
This sin x is actually sin x over 1. So fraction times fraction, we take numerator times numerator, we get sine square. Denominator is cosine x, which is cancelled away at this step. Okay, anybody needs help for 4D? Eight, 1 minus cosine square x. Okay, what shall we do first? To what? Change cosecant x to what? Got something very familiar already, right? The 1 minus cosine square, what can we do it?
Then minus 14 over sine square.
Minus
Wait, minus
14. Cosecant still, right?
So why not change to 1 square, 1 sin x?
What do you mean 1 sine x? Okay, come on. What shall we do now?
1 sin x.
You mean over? Plus 5? Like this? What kind of equation is this? Quadratic again. You know why is it quadratic? Times sine square x. 8 minus 14 sine x.
Yeah.
Quadratic again. Okay, so we have come to the end of exercise 9A, what I wanted you all to do. Attempt them again. Not now, in your free time. You judge whether you have learned. Does it take long for us to talk about the process? I don't need you all to, as long as you're confident of solving quadratic, you can stop here already. Because if you are prepared for an AMS test, you should know what these are already lah. Okay? Next, 9.2, we've got exercise 9B. Which one do you need help with? Okay, let's start with a smaller number, 2B, right? So, Now let's work together as a class. Do we start from left hand side or right hand side? 2B. Okay, so write down. Okay, what shall we do over here? What can I do?
I change cotangent to 1 over
1 plus
1 over
1 over tangent. Okay, over 1 plus tangent x. Then how?
1 plus tangent x over x.
What can we do?
The top part you make 1 to tangent x over tangent x plus 1 over tangent x.
Okay, so numerator becomes tangent x plus 1 over tangent x. Okay, then what?
Okay,
This one is the same as this one.
that's how it becomes tangent x.
Here we have tangent x over tangent x. Okay? Okay, what's the next step?
1 over tangent x.
Flip ah? Times what? Oh, okay, whatever method you all say, right, you are trying to avoid having fraction and a fraction, isn't it? This is how I recommend you all do it. Tangent x plus 1 over tangent x. So divided by, right? Divided by 1 plus tangent x. Of course with a bracket lah. So since it is a dividing by a number, we change it to multiply and 1 over. Right? Are you able to do this? In fact, you all want to skip this step also can. But it's just that I feel if you do it this way, it is very clear. What shall we do next? Cancel. So make what? 1 plus tangent, 1 plus tangent, cancel also already. Yeah, divide and flip over become times lah. Flip already. See ah. This is a division, right? This is my numerator over here. I am dividing by 1 plus tangent x. So from here, instead of dividing, I prefer to multiply, but I need to flip. And here we can cancel. Answer 1 over tangent x equals to right hand side. Proven. Can. Okay, to be done. What else do you need help with? 3a. Start with left hand side or right hand side? Left. Okay, what should we do? Hey, but wait. Can you take a close look at the right hand side? Can you take a close look at the right hand side? What is the right hand side? Tangent square x plus what? What does that give us? Secant or cosecant square? Okay, tangent square x plus 1 is secant square x. What is secant square x actually? 1 over cosine square x, right? So the right hand side, mentally, I know that it is 1 over cosine square x, isn't it? What is the significance of that if you look at the left hand side? Got the same thing, right? Effectively, I want to make the right hand side, I want to make this left hand side become 1 over cosine square x, so that it becomes secant square x, so that it becomes 1 plus tangent square x. You following so far? What does that imply about the numerator? It's supposed to be 1. Can we prove that it's equal to 1? Let's try that. What should we do? Expand. Expand? Can we expand? We can if we want to. Or there are some other suggestions. We change cotangent square, is it? Regardless. Let's try expanding. Sine square x plus sine square x. Now, cotangent square, what do we want to do with it? What do you want to do with it? You have options. Are you sure cotangent is sine square over cosine? Your tangent x is sine x over cosine x. So cotangent x is cosine x over sine x. So here we have, yeah. Okay, now that we have this, is it very clear that the numerator is 1 already? Is it clear to you that the numerator is 1? Not yet? What can we do for sine square, cosine square over sine square? Cancel. So what's left? 1. 1 over cosine square x, which is? What's next? Cannot say equal right hand side now lah. Equals secant square x first. Then this is tangent square x plus 1 equals right hand side. Okay, what's your other method? 1 plus cotangent square x is how much? Okay, so alternative solution. So left hand side, you want this to be how much? Cosecant square x over cosine square x. Okay, next. Okay, so look at the screen. This is what Kevin has suggested. Okay, he changed the 1 plus cotangent square to cosecant square. Totally okay. Then cosecant is just 1 over sine square. Then you get the same answer. Both will get the same full marks. Therefore, my point here is for identities. Remember that is for identities? Okay, but if you look at the question itself, prove each of the following identities. These are known as identities, where I have a left hand side equal to right hand side. They are always the same, regardless of the value of x. When you are doing identities question, there are many ways to arrive at the same conclusion. I'll pause here. Okay, how do I proceed from here? Please talk to your partners. Yes. Why is it the same? Okay. Annotation. How you write things. X power 4. Is it the same as x squared times x squared? Yes. Obviously, So cosine power 4x is the same as cosine square x times cosine square x. They are the same. Okay? So now I have cosine power 4x minus sine power 4x. What comes to mind? What do you think we can do? Factorize? You mean this becomes cosine square x with a square minus sine square x with a square like this?
You can put cosine square x plus sine.
Okay, one by one, please. Result. Wait. Yes.
You can put
A square minus B square. But there's no A, no B.
A plus B,
A minus B, A minus B. Okay, apply this. Yes, can. Next question. Yes. What, you mean like that?
No, you can leave that for if it's times.
Are you referring to this? Cannot lah.
If it's times, you can do that, right?
This, what you are telling me to do is to a squared minus b squared equals to a minus b squared. Cannot, cannot. Cannot. Okay, so cannot. Any other questions? Any other questions? If not, let's employ what Darius has suggested. Which square minus which square? Oh, cosine square x minus sine square x multiplied by cosine square x plus sine square x. Are you happy to see the second bracket? Yes. What is it? 1. This is just 1. Right. Okay. Cosine square x minus sine square x, what do we have? Oh yeah, it's the left hand side already. Sine square x minus sine square x equals to left hand side. Proven. Huh? Can't hear you. What do you mean, how is this possible? Hey, the rest of you, lower your volume. X squared is not the same as x power 4, yeah. Oh, okay. You are making a comparison whether these two are the same and whether these two are the same, is it? I give you another example. 5 minus 3 versus, okay, I put equal sign over here. 10 minus 8. Does this answer your question? Yeah, but they're not the same. So this one also can, right? So similarly, we realize that actually there is a very interesting relationship, that is cosine square x minus sine square x happens to be cosine power 4x minus sine power 4x. No, you cannot memorize this and use this. Wait, listen to it. Ernest, right? It's a very interesting question. What is your question? Cosine square x minus sine square x equals to cosine power 6x minus sine power 6x. Cosby is right, you need to prove it. It doesn't imply, but you need to prove it. You need to try. So you start from here. Then you will get cosine power 3x minus sine power 3x. Sorry, this one's square, and over here square. So, does this tell you whether it's same or different already?
Just like 2 square.
You can try, but at a first glance, right? At first glance, I don't think they are the same already. Uh-huh. You may get it. So what? Doesn't make sense. Okay, your friends are suggesting to answer Ernest's question, right? To prove that it is not true, you can also substitute values. What is one? You want to sub values? And then? As this one, is it? Wait, so cancel this one, is it? Are you all just talking about this portion? Okay, what about this? Okay, you cannot sub cosine x equal to 2, because the maximum value of cosine x is 1. So suppose let x be something. Is it? Okay, let x be, for example, 10 degrees. Okay, now what is your point? You want to demonstrate whether it is true, is it? Is this what you're trying to do? Okay, let's try. Left hand side equals to cosine square 10 degrees minus sine square 10 degrees. Then you get a value. Right hand side. Matthew, use your calculator.
Wait, 10.
And when you key in your calculator, you should be evaluating cosine 10, then you square it.
It's the same.
Are they the same? Same. Whatever it is, calculator. Calculator.
So Mr. Moore, is it because it only applies to like a certain, like as in you can do.
Same.
So you can do like.
Wait. Whether you use 10 degrees, 5 degrees, whatever degree is the same. That is why it is called an identity. Some other things that you will learn will be, for example, a plus b squared. It is always true, regardless of the value of a and b. Same as what we are all proving. Yes, Darius?
No, I mean, is it like one of those exclusive to, as in like, you know, the 2 square equal 2 times 2 equal 2 plus 2.
No, I don't understand.
Basically, they are the same. But
Yeah,
it
they are the
applies
same
to-
over
it
here.
only applies to 2, in number 2.
Oh, you're talking about specific cases. Yeah, then it's not an identity already. Okay, any more from 9b? Any more questions from 9b? Okay, so tip for you. Identities are very popular exam questions. O level sure will have one.
So is it the proving ones?
Okay, I've never seen two before lah.
Whoa.
Actually, it's just one. But sure.
So O level now how many questions?
I don't know, go and check with you guys.
Oh, wait, wow. Wait, do I still want?
Okay, that's the end of the homework.